So here we have another chi-squared test that we're going to talk about today, which is just another hypothesis test, which ends up using chi-square again. So the whole idea here is that now we're going to be testing for an association, which is an association between two variables. So this hypothesis test allows us to determine if two variables are connected. The null hypothesis is that there is no association between the variables, and the alternative hypothesis will always be that there is an association. And we're looking to see whether or not we can reject that null hypothesis and show that there actually is a relationship between those variables. One of the easiest ways to see this is by using a table. So here we're trying to check whether or not the shirt color that you wear has an association with the bowling score that you get at the bowling alley. So in this particular case, we're looking at you could possibly be wearing a red shirt, a green shirt, or a black shirt, and your scores can be 101 to 200 or 201 to 300. Now if you look inside this table, you see that those that wear a red shirt, 12 of them got a score between 101 and 200, and 7 of them got a score between 201 and 300. Black shirts, 5 got between 101 and 200, and 20 got between 201 and 300. Now, strangely enough, you might not think that, and this is completely made up data, by the way, but you might not think that the shirt color should have any indication in your bowling score. However, if you're looking at this table, what you might notice is that there are a lot of people getting a higher score if they're wearing black shirts versus the other colors. And so maybe this association will show up when we try to test this hypothesis. Okay, so the expected frequency is something that we're going to need in order to use the chi-squared test, just like in the previous chi-squared test. And here, the expected frequency is going to be equal to the row total times the column total divided by n, where n is the sample size. We need the expected frequency because we're going to do chi-squared, and it's going to look very similar to the chi-squared from the previous section. So here's an example where we can start to look at the expected values. So what we're going to have here is we have that the row total, we can do the column totals for each of these. 12 plus 7 is 19, 14 plus 6 is 20, and 5 plus 20 is 25. And then we have the column totals, or sorry, the row totals. 12 plus 14 is 26 plus 5 is 31, and 7 plus 6 is 13 plus 20 is 33. And that gives us a total, or the sample size, which is, if I add up all those numbers on the inside of the table, I get 64, which you should notice is 31 plus 33, and it's also 19 plus 20 plus 25. So we end up getting some nice values from that. Now, the expected values then. So the first expected value, which I like to call by E11, which would correspond to the first row, first column. That's going to be found by taking the row total, which is 31, multiplied by the column total, which is 19, divided by the total, or the number of people in the sample space. So we take 31 times 19, and then I divide that by 64, I actually get 9.20, and I'm going to round mine to the nearest hundredth. If I do this next one right here, the expected value for this spot right here, again, I'm going to take 31, because that's the row total, multiplied by the column total, 20, and then divide it by the 64, and I end up getting 9.69. And so I have expected values by doing that each time. I take the row total, multiply by the column total, divide by the total, and what I end up having is I have 9.2 is what I would expect right there. I would expect 9.69 in the next spot. I would expect 12.11 in the next spot. I would expect 9.8 in the next spot, 9.80. I would expect 10.31 in the next spot. And I would expect 12.89 in the next spot. So those are my expected values. Now, the numbers that are in black are the actual observed frequencies, and the numbers that are in red are the expected frequencies. And then the idea here is that we're going to compute chi-square much the same way that we've done in the past. we're going to take the difference of these, square them, divide by the expected, and then add up all those values. When we're looking at this, the expected for black between 201 and 300 is 12.89, but the actual observed is 20. So this is a big difference. And the same thing for the black shirts between 101 and 200. And we can start to see that there is a difference between the observed and the expected. And that big of a difference is probably going to show us that there really is an association. Chi-squared is computed the same way that we did in the past. So we're going to take the observed, subtract the expected, square that, divide by the expected. We're going to do it for each space in the table. And then we're going to add up all those spaces. So here's an example. So I want to do, I want to add these all up. And what am I adding up? I'm going to be taking, remember, I'm going to be taking the sum of the observed minus the expected, and then divide by the expected, and I'm squaring that top. I'm going to add all those up. So I need to do it for each spot. So for the 12 to the 9.2, so this is for the, for red, and 101 to 200. Let's do that one and see what happens. So I'm going to take the observed. The observed is 12. I'm going to take the expected is 9.2. I'm going to square that, and then I'm going to divide by the expected, which is 9.2. And I end up getting 0.852. So then we'll do another one. So we'll do it for, let's do it for the green with the 101 to 200. So this is the green 101 to 200. So again, I'm going to take the observed, which is 14, subtract the expected, 9.69, square that, and then divide by that 9.69. And here I end up getting 1.917. And I keep on doing that. So then I'm going to have the black 101 to 200, which I do the same exact thing. And let me just tell you what we end up getting, because we're going to add up all these together to give our chi-squared. So when I do the black 101 to 200, I would get 4.174. And when I do the red 201 to 300, I should get 0.8. And when I do the green 201 to 300, I get 1.802. And when I do the black 201 to 300, I get 3.922. Notice that each time I get a bigger number, this corresponds to something that's really screwed up in the table, and bigger numbers make a bigger chi-squared. So chi-squared is the sum of all those. So I add them all up, and when I add them all up, I get 13.467. So that's my chi-squared. Here is 13.467. So now we want to know if that chi-squared is big enough to reject our null hypothesis. Again, our null hypothesis and our alternative hypothesis for these types of chi-squared tests are always null, there is no association. Alternative, there is an association. In order to do this, we need degrees of freedom. Degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So the number of rows in our particular example, we had 2 rows. And the number of columns in our particular example, we had 3 columns. So our degrees of freedom in our particular example is 2 minus 1 times 3 minus 1, which is equal to 1 times 2, which is equal to 2. So our degrees of freedom is 2. And remember, we need to know the degrees of freedom, and we also need to know the level of significance when we look inside the table to find our critical value. And this is just the same exact thing from the last section. So let's test this hypothesis test using a critical value of 5%. So let's let alpha equal 0.05, and we're going to actually run a hypothesis test here, a chi-squared hypothesis test for this bowling scores versus shirt colors. So just like in the last section, the 2 things you need in your when you're looking at the table for your critical value, you need to know your level of significance, which I just gave, and you need to know your degrees of freedom, which we just computed. So we're looking at degrees of freedom 2, we're looking at level of significance 0.05. Now we go down and we find out that chi-squared, the critical value, chi alpha squared, you can actually plug in the alpha if you want to write it as pi 0.05 squared. This is equal to 5.991. Now this is less than, so 5.991 is less than our big, huge chi-squared of 13.467, which is equal to our chi-squared. Now, just like before, if chi-squared is bigger than chi-alpha squared, that critical value, then we reject the null hypothesis. So since this happened, we're going to reject the null hypothesis. Now, in a chi-squared test for association, null hypothesis is always that there is no association. So we reject that there's no association and support the alternative hypothesis. The alternative hypothesis is always, for these particular types of tests, that there is an association, which is the exact opposite of the null hypothesis. So there is an association. Conclude, there is an association. And since there's an association, what we're basically saying is if the numbers that we got were actually from real life situation here, then the color of your shirt does have an association to your bowling score. Whatever that association is, who knows? But that's what we're finding from this particular chi-squared test.